Hey everyone, it's Katya, and today I'll be teaching you Chapter 6, which is the standard deviation and normal model. While reading Chapter 6, please keep these in mind. The shifting or rescaling data can make it easier to understand. Standardization of data, the 68, 95, 99.7 rule and its relations to distribution, and the two normal assumptions. This slide has links to all the basic topics of this chapter. If you need help with one specific topic, please feel free to use this page because they are hyperlinked to the slides ahead. This slide right here is a basic set of videos. Miss Brown is the statistics teacher who will be going through the lesson herself, and on the other side is the overview, which is what you are watching right now. We will also be doing videos to help you with your homework, AP statistics questions, and even calculator tips and much more. This page will be set with a bunch of links, so after you've done everything you possibly can with the slideshow, please feel free to use this. There will be a little bit more help and tips on this page. Standard deviation as a ruler. Standard deviation tells us how the whole collection of values varies, making it a sort of ruler for comparing an individual value to an entire group. There are two questions you should ask yourself. Number one, how far is the value from the mean? And number two, how different are the two statistics? Standardizing with z-scores. Expressing the value in standard deviations is called standardizing. To standardize a value, we simply subtract the mean performance in the event, then divide the difference by the standard deviation. Standardizing the z-score changes the center by making the mean effectively 0, and standardizing the z-score changes the spread by making the standard deviation 1. Standardizing with z-scores. Standardized values are commonly called z-scores. Standardized values have no units. Z-scores measure the distance from the mean in standard deviations. By using the standard deviation as a ruler, you can measure distance from the mean with values that are measured on different variables, scales, units, or individuals. When a z-score is considered big, a z-score gives us an indication of how unusual a value is because it tells us how far it is away from the mean. If a data value sits right at the mean, it's not very far at all, and the z-score is 0. A z-score of 1 tells us the data value is 1 standard deviation above the mean, while if it's negative 1, the data value is 1 standard deviation below the mean. The larger the z-score is, in either direction, it is more unusual. Normal models are bell-shaped curves. They are appropriate for distributions whose shape are unimodal and roughly symmetric. The number that we use to help specify the models are called parameters. Parameters are not summaries of data. They are part of the model. Statistics are summaries of data. The normal model with a mean of 0 and the standard deviation of 1 is called the standard normal model, or the standard normal distribution. The nearly normal condition. The shape of the data's distribution is unimodal and symmetric. You can check this by making a histogram. Z-scores in reverse. Finding areas with from z-scores is the simplest way of working with a normal model. When we shift data by adding or subtracting a constant to each value, all measures of position, center, percentiles, min, and max will increase or decrease by the same constant. Spread is not affected by addition or subtraction because each value moves equally. The entire distribution just shifts. Range, interquartile range, and standard deviation do not change. When we multiply or divide all the data values by a constant, all the measures of position, mean, median, percentiles, and the measures of spread are multiplied or divided by the same constant. The empirical rule is also called the 68, 95, 99.7 rule. This is because 68% of all the values will fall within 1 standard deviation of the mean, 95% of the data will fall within 2 standard deviations, and 99.7% of all the data will fall between 3 standard deviations of the mean. Working with a normal model, be sure to make a picture. It is definitely important to make a picture. If you're on this slide, you should be making a picture. Normal probability plot. If the distribution of the data is roughly normal, the plot is roughly a diagonal straight line. Deviation from a straight line indicates the distribution is not normal. The best advice on using normal probability plots is to see whether they are straight. If so, then your data looks like the data from a normal model. If not, make a histogram to understand how they differ from the model.